Hi there. So far, we managed to create two modules. One is above the RTE and one is under the RTE. A CDD and the software component. In this video, we will try to connect these two modules and to communicate via the RTE through a sender-receiver interface. In order to achieve this, first, we need a data type. For this example, we will use a primitive data type. So we will start to create this data type. First, we will create a new arxml, which will be used to address these types. And we will call it here types. Good. Under this one, we will call it, let's rename this as maybe Autosar platform. And under this one, we do additional packages. We will call this base types. And under this one, we want to create an Wint8, a char. So for this reason, we will need a new element, which is called software base type. And under this one, we will need a base type definition. Okay, so basically this is the base type. We will rename this as Wint8. And the base type size 8. Good. Now we will do an additional element. We will introduce an implementation data type. For this one, we will create a new package and we will call this one implementation types or data types. Here we will add an implementation data type. And we will call this also as Wint8. Under this one, we will, as for the other one, add a software data def, and under this one, a software data prop conditional. Good. We will see some configurations here. So as a category, we will choose here we will have a value and as a short name Wint8. Good. Let's see some other configurations here. As a base type, we will choose the Wint8 that we created. We will skip the compo method for now and data const. And as an implementation, We will skip this one also. And I think it's enough for now. Next step will be to create a sender-receiver interface. But before that, what is a sender-receiver communication? In order to answer this question, we shall read a little bit from Autosar requirement specification. A sender-receiver interface allows for the specification of the typically asynchronous communication pattern where a sender provides data that is required by one or more receivers, while the actual communication takes place via the respective port prototypes. A sender-receiver interface allows for formally describing what kind of information is sent and received. I highly suggest you to read more about this interface in Autosar requirements. So now that we see exactly what we are following, let's try to create an interface. In order to do this, we shall add a new child, which is called sender-receiver interface. And under this interface, we will add a data element, which is called variable data prototype. Yes, data elements, variable data prototype. What we need to do here is to give a name to this interface, which is let's call my interface. Let's give a name also to this data element. These namings are used to create the APIs when generating the RTE. But for just now, as for example, we will let it like this. Good. Another very important configuration is to specify the data type. Good. So as a very simple step, I think this is enough to have defined a sender-receiver interface. In order to use this interface, we need to create some provide ports and require ports, which will map this interface. But before doing that, let's read again the Autosar requirement specification to see exactly how they defined these ports. So the port prototypes, also referred as P-port ports in some places, are well-defined connections points for communication between different software components. A port prototype, it's either required type or provide type. A required port in this R port prototype requires certain services or data, while a provide port or P-port prototype, on the other hand, provides those services or data. Two software component prototypes, in our case a CDD software component prototype and a software component type, are eventually connected by hooking up a P-port prototype of one software component type to a compatible R port of the other software component type. Good. So for this reason, I think with this information we can now see how we can create these ports. And for this one, I want to create a P-port from SPD, which is a P-port, and we call this as a short name SPD send data. And under this one, I will create a new non-queue sender com-spec. And here we will map the data element from my interface. Also mapped here. So additional settings that we can do here is and is necessary to do an init value. I will do it on the provide port or the require port, but it's necessary to do it at least once. So we can do it also here, and we will add here an init value, and we will choose numerical value specification, and under this one value numerical value variation point. So yes, numerical value variation point. It's important to specify this because we need an init value for the interface. Good. So at this point, our send data port is to be more explicitly done. On the other hand, in this component, we will try to create a require port. So we will do similarly new child, and we will choose port a require port, and we will name it TLT R port receive data, or let's say maybe get data. Good. Under this one, we will create also a non-queue receiver com-spec, and we will map the data element my interface. So we're communicating on this interface and receiving the data. Here also we will specify the interface on the port. Here we forgot to specify the interface on the send, and here we will do again the init value, which is numerical value specification value numerical value variation point. Good. So I think we are done with the ports. Now that the ports are finished, how this API will be triggered? We will come back to the software internal behavior, and under this element we have a timing event and a runnable. First, when we created the SPD software component, we added this runnable, which will be triggered cyclically at 100 milliseconds. So basically we want to send this data, for this simple example, each 100 milliseconds we want to update the data. For this reason, we need to create under SPD runnable a data send point and map the P port to that data point send. So for this reason, we will start to create an variable access, a data send point variable access, and under this one we will add also Autosar variable reference, and under this one an atomic software type instance reference. And here we will map the p-port that we created earlier. P-port. We are done on this side. So similar to this one, we go to the SPD and we will try to create under TLT Runnable, we will create a receive. Now we can choose here, we have many more options, but we will go for now data receive point by value, meaning the interface that will be generated will return instead of giving the some argument as a pointer. So we'll add a data receive point by value. Again, under this one, we will add access variable Autosar variable reference, and under this one we will add a atomic software type instance reference. And here we will map also to the R port the TLT port. At this point we are done with the ports, the interface, and mapping the ports on each runnable to trigger the API on the sender side and on the receiver side. At this point, we are almost finished. The single problem that remains is that these two ports are not linked. They are not connected. In order to achieve this, we need to create a top-level composition where we can define some instances for these components and then link them there. For this, I will create a new arxml and I will call this one connections. Okay. Under this one, I will create a package and name this one software component type. Good. So under this one, I want to have a composition software component type. What is a composition component type? You can read more in the Autosar requirements documentation, but basically it's a collection of components shortly. And for this reason, I will create a new element here, a composition software component type. I will call it composition. And under this one, I want to reference each software component and the CDD under this one by adding a new element and adding components, software component prototype. I will call this one SPD, and the type of this one is SPD. I will create another one and this one is the TLT. And I will reference it. At this point that we have the instances for these two components, we need to create an assembly software connector. And we will go here, connectors, assembly software connector. Because these two components are under the same composition, we don't need some extra delegations ports that we are not discussing now. And it's sufficient to have an assembly connector and connect directly the port defined here and the port defined in the TLT. So for this reason, I will call this one and create a provider port composition instance reference and a requester. I will map on this one the target P port, which is shown here, send data, and on the require port I will map the TLT. Good. So I think we can stop here. This is the final point, which should be sufficient to have a port which is triggered each 100 milliseconds, and the data will be put on the RTE, and then from the RTE will be read each 10 milliseconds by the TLT module. Thank you very much.